Okay, just the question. All right. So let's see if we can think about this a little bit. Let's see if we can think about this a little bit. Abisola, are you seeing this?
I'm seeing it.
Okay. So we're given, and I want you guys to talk this through with me, right? It's really pulling on your knowledge of a lot of different things, right? It's pulling on your knowledge of oxidation, reduction. Well, I'm giving away the answer. We weren't quite there as yet. But Kayla was given 3 different alcohols. So you have 3 different alcohols. They have the molecular formula C4H10O, right? So what might that be? Because they have the same molecular formula. So right away, what are they? They're all alcohols. So they all have the same functional group. But they're different in there. Like, what could be different about these alcohols? Think about that with me, because they have the same formula, right? But they're giving different different color changes with dichromates. So something is different about them that's causing them to behave the way they're behaving. And we, in week 1, I think we covered this idea of isomers and how we have structural isomers and positional isomers, where the position of the functional group might be different, right? They have the same formula, they have the same molecular formula, but the position of the functional group might be different. The structure is a bit different. Maybe it's branched in one case. There's some branching that's there. There are things that are different about them, right? And so Venita and Abisola, what might be going on here? What might be going on here? Let me just talk to me and let me know. This is a very close-knit group, tight group. So let me know, talk with me and let me know what you think might be at play here and what are we testing for and what's going on. And it's really pulling on your knowledge, right? Your understanding of all things chemistry, really, right? So talk to me, guys. Talk to me and let me know what might be going on here.
Is it that it is an isomer from the molecular formula?
Exactly, it's an isomer. So do you have any ideas how we might start drawing? Let me see if I can share a whiteboard and we can work on this and see where we end up with it. I'll probably have to stop sharing it. Let me think about it. Maybe I can write it on the whiteboard. Okay, I'm gonna do that. Let me do that. New share? Can I do a new share at the same time? Let's see. Ah, okay. What are you guys seeing now? Are you seeing just the whiteboard or the whiteboard and the question?
Just the whiteboard.
Just the whiteboard. Oh, Lord. All right. I'm going to close the question. And I'm going to write out what I think are the key points on the whiteboard, and then we just work on the whiteboard. What do you guys think about that? Okay, so let's see now. All right. So okay. Let me pull it up here. So guys, just be thinking about what might be going on from an isomer standpoint, right? Benita, definitely it's your question. So I'm gonna want you to talk to me, unmute and talk to me and let me know where you are. So I'm not gonna just give you the answer. We're gonna arrive at it together, okay? So unmute yourself and talk to me and let me know what you're thinking, where you are as far as this question goes, and kind of so I can see what you've done so far, in terms of thinking about it. So it's C4H10O. So guys, what is C4? C4 is what would be that homologous series of alcohols? The mic in the device is giving trouble. Okay, so Venita's saying that she can't speak. All right. So type in the chat then. What is C4? C4 is what homologous series would that, well, the homologous series would be alcohols, right? That's the, yeah, so homologous series of alcohols with increasing carbon chain. But what I'm asking is what is this, the prefix that we use for C4 compounds? If it's 4 carbons, how do we refer to those? Abisola, do you know? Like for C4, what do we refer to those compounds that have 4 carbons as?
I'm not sure.
You remember bute, so you have meth, meth, eth, prop, bute, pent, right? Hex, hep, remember those things? So like it would be like this, bute, right? So this, so what we're having here is this is the molecular formula, and they're saying that there are like 3 isomers of it, right? 3 different alcohols, right? And but they all have the same molecular formula. So like it's like it would be a variation or varieties of butanol, right? There are varieties or different isomers of butanol, which has 4 carbons, right? 10 hydrogens and 1 oxygen, right? So we can start to draw structures for butanol. So Venita says butane, but it's actually butanol. It's the prefix that we're concerned about, and you got that right? It's butanol. That butanol because it's alcohol, right? That's the we're in the alcohol homologous series, right? So it's butanol. But there are 3 different alcohols with 4 carbon each. So they're like isomers, and you can have positional isomers, where the position of the OH is changing. So it's on different carbons each time. Or you can have branching happening. So you have branch chains, and those will affect the reactions or the character of the alcohol. So, remember, I don't know if you guys learned this, but you have primary alcohols, secondary alcohols, tertiary alcohols, and that's just based on the arrangement of, I guess, the carbon backbone can be shifting as well, right? But it's still 4 carbons, but the backbone is shifting, the positional, we can have positional isomers, so the OH is in a different position, but the formula is still the same. Right, are we all clear on that? I see that Jules just joined us. Jules, welcome. Are you unit 1 or unit 2? Jules? Are you guys following so far? I don't hear anything or see anything in the chat. Are you following what I'm saying here? I want it to be interactive because I don't want to give you the answer, just give you the answer. I want us to think it through so that if you're given this in an exam, you'll be able to go through a similar approach to solving it, right? So okay, so it's 3 different alcohols. Let me write the rest of it now. Only 2 out of the 3 guys resulted in a color change when you from orange to green, when you add acidified potassium dichromate, right? So I'm gonna write that down. 1 of 2 color change, orange to green, right? Orange to green. With acidified. Let me just go do a shorthand. Acidified potassium dichromate, right? And guys, what is potassium dichromate? What is this? What is this that they're testing it with? What is this? What does a test with potassium dichromate tell us? Because guys, this is the key to this question, right? We have to know what this is doing and what this color change represents. And that the fact that only one out of one, what did I say? Only two out of the three, on the fact that only two out of the three of them gave us that color change, it says a lot about the structure of the alcohol, right? So yeah, please talk to me. Talk to me. Jules, you're awfully quiet. To test for sulfur dioxide. Well, I guess more, you can use it for that, Benita, but more broadly, with acidified potassium dichromate, like I think it tests for like the oxidizing power or oxidizing ability. You have an oxidation reduction event that goes on. And from that, we can glean whether or not what we have, right, is oxidizable or reducible, right? So it's like a redox kind of a situation going on whenever we're using potassium dichromate, right? Because you have a reduction of, I think you generally have a reduction of that dichromate ion, and that's what results in that color change that we see from orange to green, right? So you'll have alcohols that can cause that effect and alcohols that can't, and that's based on the structure of the alcohol. Is that clear so far? Are you following? Let me know if you're following that so far, right? So that's V1. So that's 6. So that's the oxidation state is 6. For this, I'm just putting it here because it's a reason why they're telling you what the oxidation state of the potassium dichromate is, right? The oxidation number is important because it's like based on this redox principle, right? So Venita is saying this is when the alcohol is oxidized. Is that true, Venita? Let me know. Is that true? When the alcohol is oxidized, what happens as a result of the oxidation of alcohols? When you oxidize an alcohol, what happens? The potassium dichromate will act as an oxidizing agent. An oxidizing agent oxidizes things while it itself is reduced, right? So as a result of that reduction that takes place of that acidified dichromate ion, we see that color change from orange to green, right? So the dichromate, potassium dichromate, is an oxidizing agent. It's going to oxidize the alcohol. It can oxidize 2 of the 3. 1 is not oxidizable, and that should give you a hint as to what the structure might be. But 2 of them are oxidizable by potassium dichromate. And so that's why when you add that, the potassium dichromate itself, it oxidizes the alcohol, but it itself gets reduced, and it being reduced is manifested in a color change from orange to green. So are we all clear on that? Are we all good up to that point as to why the color is changing and why it's not?
Yes.
Okay. All right. So what now? The part where we're at is figuring out what's actually going on from a structural standpoint. 2 of the 3 can reduce dichromate or can be oxidized by dichromate. 2 of the 3. So what does that tell us about the structure of 2 of the 3? That's where we are. And I want you guys to answer. Or is it, have you guys learned about this or no? Or am I teaching you this right now? Do you have any ideas or no? Because I'm assuming that you were taught it, Benita, which is why they're asking you. I'm assuming that you have some basal level of knowledge on it. Otherwise, they wouldn't be testing you on it. Is that correct, Benita? Or are they expecting you to go and research this stuff and figure it out on your own? Okay. Okay, I see. All right. So, okay. So I haven't taught you guys extensively about all the different functional groups, but you see alcohols. Okay, so as I said, the potassium dichromate is an oxidizing agent, right? So it can oxidize things. And by oxidizing things, I mean that it can cause things to, so we can define oxidation in a variety of ways, right? Oxidation can be when a compound gains an oxygen, right? It can be when a compound loses hydrogen, right? It can be when a compound loses hydrogen, that's oxidation too. It can be a loss of electrons, right? Because oil rig, right? It can be a loss of electrons. And it can also mean that there's an overall reduction in the oxidation state or the oxidation number. So those are just definitions for oxidation from an oxidation standpoint. So when I say that potassium dichromate is an oxidizing agent, it can either cause that change to happen in another compound. The compounds of interest here being the alcohols, right? So the potassium dichromate can cause the alcohol to gain oxygen, lose hydrogen, lose an electron, cause an increase in the oxidation number or the oxidation state. So those are the things that the potassium dichromate as an oxidizing agent is capable of doing. While it itself, the potassium dichromate is reduced in the process, and that reduction results in that orange to green color. Okay. So where we are now is then we have, I said we have three main classes of alcohols, right? In terms of from a structural standpoint, right? We have primary alcohols, right? So we have primary alcohols. We would generally write them as, you can write one, I guess it's kind of like first degree alcohol is a primary alcohol. You have secondary alcohol, right? Secondary, I'm not gonna write out the entire thing. And then we also have tertiary alcohols, right? Now, a primary alcohol, I have to show you the structure, otherwise it's not gonna make sense. But are you guys familiar with this concept of primary versus secondary versus tertiary, or is this news to you guys right now? Let me know in the chat or just unmute and let me know if you're comfortable, if you're familiar with this concept of primary, secondary, and tertiary alcohol. Let's see what you guys are saying. Not too familiar. Okay, so for primary alcohols, what can I erase off of this? What can I erase? Oh, maybe I'll write in this corner. I haven't written over here as it. Let me write over here. So primary alcohols, the OH group, because okay, remember that alcohols, the functional group is OH, right? The functional group is this OH, right? For alcohols, that's our functional group. Functional right? That's our functional group. Let me circle that in a red thing. Do I still have my pen? Okay, so this is our functional group, right? This is the functional group. This is the thing that makes it an alcohol. Like this is it for alcohols. The OH group is what gives its character, its chemical properties, the kinds of reaction that is then able to partake in is as a result of this functional group. That's that OH group, right? All right. So the position of that OH group is kind of what determines whether it's primary, secondary, or tertiary, right? So for a primary alcohol, the OH group is at the end or the last part of the chain. So OH, let me write that. 1 degree, so that's primary, OH at end or last part of chain, right? And then the secondary one, the OH is in the middle of the chain, right? And the OH is a functional group in OH in middle of the chain, right? So that's that for secondary and tertiary now. For tertiary, it's the OH is like a branch point. So like where you have like branching is where you'd have this OH group. I want to draw it. I would rather drawing this to show you guys, but I think that we can just do that. I can just tell you that, guys, tell you that for now, and you later look a little bit deeper into it. But I want to like talk about what's happening from an oxidation standpoint and a reduction standpoint, and why two of them have color change and why the other one doesn't have a color change, right? And that's something that's largely based on the structure. And as I just went through primary, secondary, tertiary, like that's why some of them change and some of them don't, right? So the question is asking you, Benita, to propose a hypothesis for her observation and design an experiment to test your hypothesis. So Benita, what would be the hypothesis here based on what I've said so far? Right? Without me going any further and giving you the answer. The hypothesis is just an educated guess as to what might be going on here. Right? So what would be your educated guess? I mean, I've already told you the answer, I think, in terms of what's going on, but I want to see if you're grasping it and if you're picking it up. So you can write in the chat because you say your mic is giving problem. And then also, Abisola, definitely feel free to talk with me and let me know what you think is going on here. So what's your educated guess? What's the hypothesis? I've essentially told you guys, but I want to see how much of that you are grasping, okay? So Benita, write that in the chat. Abisola, unmute yourself and let me know where your thoughts are with this, okay? Yeah. Any thoughts? Any thoughts? Any thinking? Anything going on there? Okay, Avenita, I hear you. Abisola?
Miss, I'm trying to put one together.
Put one together, you putting a thought together? So I'm giving Benita a minute, I'm giving you a minute, Abisola. So let me know what you're thinking. I didn't give you all the answer, but I gave you enough for you to be able to kind of deduce what's going on. Okay? All righty. Where are we? Okay. So Abisola is saying that she's not too sure. So essentially, maybe I'll do this. I don't have the space there and I don't want to erase this stuff because I think it's all important. But essentially, I just taught you guys about primary alcohols, secondary alcohols, and tertiary alcohol, right? Now, in terms of where the functional group is, the OH group is, like that's what determines whether it's primary, secondary, or tertiary, right? Primary alcohols are oxidizable because the OH group is at the end, so you have more leverage, right? And I guess in terms of how would I say? Its ability to be oxidized, more oxidizable. It's a more oxidizable hydrogen, right? It's a removal of hydrogen. It's a more oxidizable hydrogen because remember we had a definition for oxidation as the removal of hydrogen. So that hydrogen, because it's more exposed, it's more removable in the primary alcohol case. And so primary alcohols can be oxidized to aldehydes, and then after that you can get acids out of it, carboxylic acids, right? So in light of what I just said, potassium dichromate is a powerful oxidizing agent, so it oxidizes something else. So the potassium dichromate can oxidize the primary alcohols to form either an aldehyde and then after that acid, a carboxylic acid, right? Secondary alcohols are the same. They're oxidizable, right? And so the potassium dichromate can oxidize that secondary alcohol, and what you would get from the oxidization of a secondary alcohol is what we call a ketone. That's a different functional group, right? So those two of the three are oxidizable, right? And so they are indeed oxidized when we expose them to acidified potassium dichromate. So that's kind of the answer, Venita. So the hypothesis could then be something as you could say, oh, 2 of the 3 alcohols are oxidizable. So I hypothesize then that we have a primary and a secondary alcohol and also a tertiary. But the tertiary cannot be oxidized. The tertiary is not oxidizable. And so when you react to that particular one with potassium dichromate, you don't see a color change because it's not oxidized, right? The alcohol is not oxidized by the dichromate, and the dichromate by extension is not reduced as a result of that interaction. And so there's no color change that you see from a dichromate standpoint, right? So the primary and the secondary alcohols are oxidizable, right? And they are oxidized and you see a color change, but the tertiary one is not oxidizable and it's not oxidized, so you don't see a color change, right? So your hypothesis is that, well, it looks like we have a primary and a secondary and a tertiary. Primary and secondary undergo oxidation, and that's why we see that color change. The tertiary does not. How can I test this? How can I test this? Well, you do that, you probably would need to do another kind of a test. You're given your results as to what happens with the dichromate. So maybe you could use another oxidizing agent that whenever that is successful in oxidizing a compound, there's a color change that accompanies that, and you can see that for yourself, and then you can just confirm what you're seeing with the dichromate. Does that make sense? I hope that makes sense for you guys. But if not, I'm happy to explain again. But does that make sense to you guys? Just let me know. Indicate and let me know. Abisola, you can speak, so definitely speak. Unmute and talk to me. Venita, please write in the chat what's going on.
You can go over it one more time.
Okay, so what I'm saying is that you have these, so within the family of alcohols, there are levels to this, right? There are levels to this. You have a primary alcohol, you have secondary alcohols, and you have tertiary alcohols, and that's structure dependent, right? Now, the hydrogen from that OH group, right? Because the OH is a functional group for alcohols that I showed you here. I wrote it here and I boxed it in red. This hydrogen is more oxidizable. And by that, I mean you can take it off, right? When it's in a primary alcohol state or a secondary alcohol state, right? Tertiary, not so much. Tertiary, you're kind of stuck with that, right? So what happens is if you expose it to an oxidizing agent like potassium dichromate, right? The potassium dichromate is gonna oxidize it and you're gonna remove that hydrogen, right? You're gonna change that oxidation to you're gonna oxidize that alcohol. And that oxidation you can measure, you can track based on the color change that happens as a result of the dichromate being reduced. Oxidizing agents oxidize other compounds while they themselves get reduced, right? And because the dichromate is reduced whenever it oxidizes the primary and the secondary alcohol, you see that color change from orange to green. But the tertiary alcohol, because it's not oxidizable, when you add dichromate to the tertiary alcohol, you're not going to see any color change because it's not oxidized. And because it's not oxidized, the dichromate is not reduced. And so you don't see a color change from orange to green. It just stays the same, right? And that's because of the structure of these alcohols that are in question. We have the same molecular formula of C4H10O, but the difference is in the structure. They're structural isomers of each other. And in that structure, you have a primary structure, a secondary structure, and a tertiary structure. Primary and secondary structures are oxidizable, tertiary structures are not. And you can test that using a powerful oxidizing agent like potassium dichromate or another one of your choice to just kind of confirm that what you're seeing with the dichromate is actually correct. So my homework for you would then be to go and research another powerful oxidizing agent. What's the accompanying color change? And then you can say, oh, I'm going to test it with this. And if it's primary, this is going to happen. If it's secondary, this is going to happen. If it's tertiary, this is going to happen. And convince yourself that, oh, it's as a result of the oxidizing ability of these alcohols. Does that make sense? Well, what did you say, Abisola?
I was saying it makes sense.
Okay, so that's kind of what that's what the basis of this is. It's understanding that different structures give you different things. Different structures can do different things, and you have these class of compounds that are either oxidizing agents or reducing agents that can tell you what's going on because they can oxidize or reduce or whatever the case may be. They're able to do that, and there's a color change that accompanies that. And from that, you will be able to say what's going on there, okay? So Benita says that's understood. I hope that was helpful. And I'm always like leery of like helping students with these things because I don't want to give away the answer or give you spoon feed it to you, but I want you to think about it critically, right? And so when you're faced with a similar problem, you know how to think about it and think it through and work it through for yourself, okay? Okay, so this was like a very practical session.